Hi everyone. I'd like to also wish you Happy New Year. So in this video, I just want to go through some of the new open source projects that are based on 5G core. And one of the interesting projects which I came across is actually called eUPF, and then the eUPF is based on eBPF. So recently, for the past 1 or 2 years, eBPF has been gaining traction, especially when it comes to uh, enhancing the throughput or observability or logging or tracing um, in Linux or also in other platforms, not only Linux. So, but what is a little bit missing on the telco side is having to get some of the CNFs to also make use of eBPF. So one example of this is eUPF. So there are other projects. For instance, Open Interface also has I think they just released a UPF also that is based on eBPF also. So I just thought of let's go through this and then let's see what some of the interesting features that we see here. So like I said, that it's eUPF and this is the GitHub page. And then you see one thing that you will quickly notice is that this project is not trying to do everything right. So they are picking just the UPF and they are focusing on it. And there are advantages to that, especially when it comes to the development effort, right? So when you focus on a CNF, for instance, like the UPF, you tend uh, to focus, I mean, you tend to use more resources in making it performant and then to making it something very good, right? So instead of having to do everything all together. So I'm not saying all other projects are not doing a good work. So, but then you having a specific, focusing on a specific part of the 5G core also gives you the advantage of optimizing the code, and just because you have one thing to work on. So the developers also they've made efforts to use the control plane function from several other 5G core like the free 5GC, Open 5GS, and Open Air interface, right? So that means that what you can do, I mean, since it's just the UPF, you actually need the other 5G core components like the AMF, SMF, and all that. So what you can just do is you can actually deploy them. You can use the existing open source projects for the control plane, and then you just don't deploy the what do you call it, the UPF. So once you do, so you just use just the 5G core control plane, and then you connect it to this UPF, and then you have your full 5G core deployment. So that's what is being explained also here. So you see here all these guys is from other projects, while this will be your eUPF. So also since it's based on eBPF, so they have some prerequisites like the kernel versions that it has been tested and known to work with. And then one other, apart from all the 5G UPF features, you see from here that the developers have made a good effort. If we go to docs and then you go to deployment, you see here that they've made a lot of efforts to create, especially M charts that will make it easier for you to test run this. So for instance, here you see you have a test deployment with using Calico also as the BGPPF for the UPF. So one thing they also tried to do was that also making use of Calico. So Calico is the CNI, right? So so this is the first time I'm seeing this kind of implementation personally, I don't know of others, right? So they've tried to like, okay, since you are using since Calico supports BGP and it's already doing NAT, as in it's already doing NAT towards the internet, right? So why not use the same concept and then use the UPF as a BGP pair, and then let Calico do the NATing to the internet, right? So this is one of the other interesting features which I've also noticed there. So yeah, you see that they already have a very good make file, right? And then they are also reusing some of the M charts from OpenVarsor, right? And advantage of this is that they are not like doing everything from scratch, right? So if you have already existing M charts, why do you need to create one all over again? So the only thing they did was, of course, they have their own mchat, and then the cool thing is that they also have a Helm repository, right, which is based on OCI. So this is one of the few latest ways where you can actually distribute your Helm chart also using the OCI repository. So yeah, you see they have their Helm chart, which is cool because not all projects actually have a Helm chart which you can make use of. But then every other Helm chart you see here is actually from other projects. So you see here that all the core functions there, you see they are making use of the Open5GS. The only thing that is here is that they are not installing the SMF, and I'll give you the reason why they are doing that. So for the SMF, they tried to is one the reason the SMF was abstracted away from there is because uh, the UPF, you need to adjust the config map so as to suit the eUPF. And the smart thing which they did was that first of all they create the SMF M chart, but then they what they do was to make it to be the replica to be zero, right? So once they make the replica to be zero, I mean by default the replica will be zero, but then it's good if we just check the SMF ems dot value. I mean ems value file. So you can see here that the replica number of replicas is zero. So what this means is that the SMF M chart will be deployed fully, but then the actual pod will not be running, right? And then if you come back to the make file, yeah, you see that once the SMF is deployed and no pod is deployed, and what they do is now to replace the upstream config map and replace it with the one they've modified there. So with this, since it's a bit challenging to modify the SMF upstream Elm chart, so instead of creating this all the way again from the beginning, so it was a very, very cool way to for me to see that they were able to adapt this and come around with a workaround. So if you now look at the SMF config map here, so you go to the manifest and then you come here, then you see under the UPF, you now see that they are actually adding the UPF, right? Which would be the service name for the UPF. So by default, the UPF is deployed as I think it's deployed as stateful set, but you also have the possibility of also deploying it as a deployment So so that's another example of what how they were able to make use of like the upstream and then make this to work. All in all, this I think making M charts available and even giving examples of how you can use them with upstream, other upstream open 5G calls is encouraging. So you can play around with, you can see they have a sample deployment for the USCL with free 5GC and some other stuff with BGP. I've not tried most of it all, but I think it's what I try. And the one that actually piqued my interest will be the one with the scaling eUPF, whereby what they are trying to do is like, and then you see, so it's work in progress, right? Whereby you want to have more than one UPF, but then using the same UAIP pool. Although, I mean, in the telco networks I've worked with, you hardly see this. I'm not sure, but the ones I have worked on, you hardly see UPFs having using the different, I mean, the same UAIP pool. But then it's cool. There may be reasons for that. I'm not sure what could be the reason. Maybe there is some requirement for that. So I created a discussion also on the GitHub repo to just try to demonstrate one way that it could be solved. So in my case here, what I'm proposing is that each of the UPF will have a dedicated VRF on the FRR port. So when you have these different VRFs, right, what you do is that even though, and then you do, so let me show you some of the code so that it will be easier to explain. So this is the eUPF one, the first UPF. You can see it here. And then you see we are first of all creating a route table, right? And then I'm saying that, okay, all the any traffic that comes from this UAIP pool should go to this route table, and then it should make use of this will be the default route for that route table. So, and this 101.1 is actually the IP address of the VRF1 NAT. While if we check for eUPF2, we'll see that something similar also. So you can see that the default route is 101.2. So in essence, you have actually created a separate path here, even though you still have BGP running between them. But then in each of the VRF, which is unique, the 10.11.0/16 is going to be a unique path all the way through, so that if the traffic comes through eUPF1, all well and good, the FRR will treat it as a separate VRF. And then if it comes through eUPF2 to come through, I mean, it will be treated by the VRF2 on the FRR. So this is an example of what I propose. So also, if you have some ideas about how this also can be solved, you can also maybe chime in here and then make just add some of the ideas. To give you just a brief run through of, just to show you how it's all working in my cluster. So I'm running them all in the Open5JS namespace. So you can see this is the FRR. You can see this is the eUPF1, eUPF2, and then you have the UE SIM1, UE1, UE2, and then you have the Gnode B somewhere here. So this is the Gnode B. So in essence, if we connect for example to the UE1 and you do a ping to the FRR interface, you can see that we have connectivity. And then if you go into the second UE2, but for the second UE2, the address will be .2, which will be the FRR. I mean the VRF of the second VRF in the FRR pod. So this is just to give us an example of how this how this can be done, and also to give us like a gentle introduction to the project, the eUPF project. So I'll appreciate if you guys can also try this project, because the more we try and give ideas about this project, even though we may not be able to contribute code, or if you could contribute some code improvement also to it, I strongly encourage you to do that. If not, try to test it as much as possible, and your feedback, your suggestion will go a long way in making this project. Thank you, and see you in the next.